Okay, so we have the question 2. Mm, in the question number 2, we have a rubber ball of mass 37.5 grams is dropped from a height of 1.8 meters onto the floor. The velocity of the ball is reversed by the collision with the floor, and the ball rebounds to a height of 1.55 meters. What impulse was applied to the ball during the collision? So we have a ball of mass 37.5 grams. First it is dropped vertically downwards, and this distance is 1.8 meter. So in this case what I can do is that first I will apply the principle of energy conservation. So at this point the ball has a potential energy of, it is basically having the gravitational potential energy, so it will be mgh, and when it comes here, that potential will convert to kinetic, so that will be half mv square. So I can use the conservation half v square, I can cancel out mass, so eventually my velocity will become square root of 2gh, where h is this height. So I can calculate the velocity, it will be 2 into 9.8, our gravity, acceleration due to gravity, and we have height as 1.8. So my velocity will become, it is 2 times 9.8 times 1.8, square root of answer 5 point, the 9.8 1.2, I'll just again take this 2 times 1.8 times 9.8, it is coming out as 5.939, and here they have 5.511. Okay, so the first one is 5.939, yeah, 0.939 meter per second. So this is the velocity at this point. Now when the ball reaches at the ground level, then it is rebounding to a height of 1.55 meters. So we need to calculate the velocity at this point, and we can say that this is a collision. This is not the elastic collision, but this is a collision, and at this point the ball has a potential energy. So we'll use this same principle again, and we'll calculate this. So at this point the ball will again have the potential of mgh, which is the gravitational potential, but here it will be in the negative side, and basically the ball is overcoming the gravitational force in moving upwards. And at here it again has a velocity, so we can use the same formula. So v will be again 2 times g is again 9.8 and h is 1.55. So my next velocity will become 2 into 9.8 into 1.55, 5.511 meter per second. Now to calculate the impulse, so the impulse can be calculated by, let me just cross check this formula. Yep. So the impulsive force F can be calculated by impulsive force, which is nothing but force into time, and which is nothing but mass into change in velocity. So mass was, for my ball the mass was 0.0375 grams, and for the change in velocity we'll take the initial velocity, which is this one, and we'll subtract it from subtract 5.511, the final velocity, from the initial velocity. So I have this 5.939 minus 5.511. So this is 5.939 minus 5.11 into 0.0375. It is coming as I made a mistake here. So basically this velocity was having a negative value because this is going in positive upward direction, and this velocity is having a positive value. So here we should have a negative sign also. So actually these both will add up. Yeah, the velocity is coming, one is coming downwards and one is going upwards. So yeah, there will be a change in sign, because actually the force here, it should be a minus, because it is overcoming the force. The sign should be minus in this case. And okay, so that is all. I'll just correct the mistake. 5.939 plus 5.511 into 0.0375, and my impulsive force is coming out to be 0.429375 newtons. And the solution also given by Junior Tutor is the same. So given, just a minute, given solution is correct, good work. And the solution is correct.